Hi, good morning to everyone and welcome to this video. My name is Carla Cabanes and I am one of the programming and robotics teachers of La Purísima Franciscanas of Valencia School. Today I am going to talk about sustainability through programming and robotics. And I want you to see our projects we did last year, and I am going to show you step by step the process and the results. I hope you enjoyed this video and let's start. Okay, first of all, who did this project? First and second year of high school students, and they had to create an app or a prototype for smart cities. And we have to remember that a smart city is a place where traditional networks and services are made more efficient with the use of digital solutions, and this is for the benefits of its inhabitants. And why did we do that? We were looking for economic development and environmental preservation. We were looking for sustainability and especially sustainable technology. And sustainable technology is a term that describes the kind of innovation which considers natural resources and fosters economic and social development. What is the same? It is looking for a balance between both of them. The goal of these technologies is to drastically reduce environmental and ecological risks and to create sustainable products. But how are we going to do that? We promote the use of sustainable development goals in learning so that children can contribute to a better future for all. We try to keep working on these goals, and throughout the course and all the subjects, all the students learn about the 17 SDGs. And how do we do that? We try to follow the STEAM methodology, and this means science, technology, engineering, arts, and maths. This is the combination of all these areas, and students are empowered to be curious learners who seek creative solutions to questions that they usually can't just reach for online. So they have to be creative, and in the near future they are going to be more successful. Okay, and now I am going to show you our projects step by step, but they are their projects because they did most of the work, and I am going to talk about all the steps we follow to get to the solutions. First of all, they had to identify the problem. They had to think about what do we need, what problems do we have, can we improve something, how can we do that? So they were looking for information, and they were doing a lot of hard work looking on the internet and discussing with the partners. These are some pictures of our students, and we can see them looking for information, discussing, and writing down all the notes they found on the internet or wherever. These are 3 examples of problems they found. For example, security at night. They were worried about dark and lonely streets, about traffic pollution, and inefficient crops. For example, we have a garden in our school, and it is complicated to take care of it during summer, for example. The second step in our process is to design. Our students had to create the sketches, the planes, the 3D designs. They did all the work on their own, and they use software, computers, and printers. For example, in the first picture we can see 2 students and 1 teacher. designing with the computer. And in the second picture we have a screenshot of the program they use to design, and it's called Tinkercad. We are talking about it later. And in the third picture we have a photo of our 3D printer. We have two printers in our school, but this is the newest one, and you can, I don't know, you can see the screen with all the data, temperature and the process. The third step consists of looking for materials and tools, and students had to question themselves and they had to think, which tools do we need? Do we have to order something? Do we have to buy it? Or can we reuse materials from other projects? And the question was easy to answer because they had a big class with lots of materials, lots of sensors and boards, and we just had to buy a few things, but most of the material we have it in class. First of all, we had to use an Arduino Nano IoT. This is a programming board, and it can use Wi-Fi to send and receive data from the cloud. Then we had to use protoboard and wires. These are very cheap materials. Then they had to use sensors, LEDs and actuators. These are some examples: the distance sensor, the movement sensor, push buttons, LEDs or servo motors. Other students used other sensors or actuators, but these are the most representative ones. And they also had to use tools. They had to learn how to use pliers, thin welders, electric drills, and multi-tools. We were very pleased to show them how to do it, and we always used goggles and gloves, and they were protected all the time. Finally, we have the building and programming step. This is the largest one, and this is the step our students like the most, and me too, and I think that the other teachers too. And they had to print the structures using the 3D printer, and they also had to design and program the apps and the Arduinos. They had to create also a database with Firebase DB, and we are going to see all the software they used and all the resources. They are all free. You can download them and use it in your schools or at home. For example, the software we use for the 3D design is very simple. It is called Autodesk Tinkercad. You can register, you can create a class, and you can see your students' daily work. And it's very simple and very intuitive. We also used another different one for the 3D printer. This program turns the design into instructions for the 3D printer, and this is also free. It is called Ultimaker Cura, sorry. And here you can see how much plastic wire called PLA, how much plastic wire are you going to use in your design, and how much time it will spend. Then we have the software for creating apps. And for creating and programming apps and Arduino, we had two softwares. On the one hand, we had App Inventor, and this is a very simple tool because you can program using blocks, and you just have to join the blocks to create orders for your mobile phone. And on the other hand, we have Arduino. Arduino is a little bit more complicated to use because you don't have blocks and you have to write all the code on your own. And we can say that App Inventor, we can use it from, I don't know, 13, 12-year-old students to the oldest ones. And Arduino, it's better for more or less 17, 16, from 16 to 18-year-old students. And finally, we have Firebase DB. This is a data storage and management software, and we are going to connect it with our Arduinos, and they are going to be in contact all the time, sending and receiving data. And we can use those data to get conclusions and to solve problems, for example. These are some pictures of the process. Here we have our students doing the designs and connecting wires. Finally, after all of the hard work, these were the results. And we have a video here which sums up all the work and shows you the specific projects they did and a little bit more information about the projects.
Bienvenidos al proyecto Smart Cities del Colegio La Purísima Franciscanas de Valencia. Mediante la programación con Arduino, enviamos y almacenamos datos en la nube que pueden ser manejados y estudiados a través de aplicaciones. El reto de este año consiste en crear dispositivos y aplicaciones que hagan que nuestras ciudades sean más seguras, eficientes y respetuosas con el medio ambiente. Tanto el diseño como la programación y la construcción de los dispositivos corre a cargo de nuestros alumnos y alumnas. Durante secundaria aprenden a programar con Arduino, hacer aplicaciones con App Inventor y hacer diseños 3D y simulaciones con Tinkercad. De esta forma, llegados a bachillerato, se convierten en unos verdaderos makers. Algunos de los proyectos propuestos por nuestro alumnado son una aplicación que fomenta el reciclaje a través de premios y recompensas, un sistema de alumbrado inteligente que permite realizar llamadas de emergencia, sistema inteligente de aparcamiento por toda la ciudad para reducir las emisiones de carbono, la creación de un huerto inteligente con sensores de lluvia, temperatura, humedad, luz, presencia, gases, que envían estos datos a la nube para poder almacenarlos y mostrarlos en una aplicación. Este último proyecto lo tenemos implantado en el huerto de nuestro colegio y todos los datos son visibles a través de la aplicación S-Garden.
Well, now you have watched most of our projects. Have you liked them? Well, you are able to make your own prototypes and apps just for free or with a very low cost price. I am going to give you an estimate budget for an example project. The software we have used is completely free. You can use it with Windows, Linux or iOS, and it consists of Autodesk Tinkercad, Meet App Inventor and Firebase, which can be used online, and Ultimaker Cura and Arduino, which are programs you have to download to your computer. Well, this is a bit more complicated because 3D printers are expensive, not as expensive as people used to think, but if you want to have one in your school, you have to buy it, and the cost is between 200 and more or less 400 euros depending on the quality. You have cheaper ones and more expensive ones, but more or less the most accurate printer for a school, I think is the Ender 3 or 4 or 5, and we have the Ender 3 Pro, and it has cost 270 euros. When you already have a 3D printer, the rest of the material you have to use is PLA. It's a kind of plastic wire to construct the figures, and it is sold in a 1 kilogram pack, and it costs 20 euros. We have here a picture of a box, and this is made by PLA, and the total cost of this box is approximately 0.60 euros. The electronics depends a lot of the project you are making, but here we are going to use an example, the Secure Street Lights project, and we are going to see how much does each component cost.
Let's start with the budget, and first of all we have to use an Arduino board. This is not the original one, this is just a clone, but this is a cheaper option. This costs between 5 to 7 euros more or less, and this has not Wi-Fi. If you want one with Wi-Fi, you have to spend more or less 20 to 25 euros. This is a cheaper option. Then we need a breadboard or proto board. This is used to connect wires and do the connection between components and the Arduino. So for doing these connections, you need wires. Okay. For example, I have here some wires. They have pins, so you can connect them easily. You just have to put it here, and then for example you can connect to the 5 volts pin here, and more or less this has a cost of 50 cents, and a pack of wires is more or less the same, 50 cents. Now we will have to get some sensors. This is an ultrasound sensor. This can calculate the distance between an object and the sensor and send the information to the Arduino. This has a cost of more or less 1 euro. We also have passive buzzers. These are buzzers which sound in a determinate frequency we choose. And what's more, we need switches
or push buttons. The total cost of the buttons and the buzzers is more or less 5 cents each one. And what is more important for our street lights are LEDs. We can choose the color we want. We have different features depending on the kind of LED we are using. And this is very important to read because here you have the maximum voltage and the maximum intensity we can use with each LED. So to control the intensity and the voltage, we need to measure resistance, and we need to choose the best resistance to each LED. So the total cost of a box like this is 4 or 5 euros. Imagine each LED can cost easily 1 cent. And it's the same with the resistors. So for this project we have used one Arduino, one breadboard, a pack of wires, 3 sensors like this, 3 push buttons, 3 buzzers, a data wire to connect the Arduino to the computer, and more or less 30 LEDs. This is a total cost of more or less 10 euros. So we have finished. Thank you for watching, and I hope you have enjoyed the video. I am very pleased to be here for the Erasmus Days, and if you have any question or any doubt, please let us know by scanning the QR code with your phones, and it is going to appear on the screen. And that's all. Thank you for watching.